Welcome to another episode of Tech Talk. Remember, my members always get to see my new videos first. Subscribe at www.patreon.com/12voltvids to see my newest videos up to a week before they become public. So let's take a look and see what we got on tonight's show. Today I have a Pioneer VSX D608. This is a digital sound processor receiver. I have no idea what's wrong with this one, so let's turn it on and see what happens. See if I can get my test transmitter to tune into this thing, which is 87.5. There it is, okay. And I don't hear any sound. It's tuned, it's showing stereo. So there should be sound. Speakers. It's full. There's the problem. The volume control doesn't work. I can't turn it up and down. If we look at the digital display here on the front, probably just pop my speakers, but look at this. I can't turn the volume down. Cranking it all I can, nothing's happening. Okay, so it looks like we have a problem with the encoder. Now, of course, this thing uses a digital volume control. The control up front here, it's just turning an encoder switch, which should tell the DSP to turn the volume down. And I'm thinking possibly the encoder itself is where the problem is. My microphone's in the way. Could be the encoder itself, which is connected right up at the front here. First things to do on this is to, well, of course, unplug it first of all, but I'm going to pull the front board off and we'll check that encoder switch out and just see whether it's the encoder switch itself that's gone bad. Typically, how these encoder switches work, if I can draw a little diagram here just to kind of illustrate how they operate. Now, these encoder switches are much like the rotary encoder on a VCR. Typically, there's 3 terminals, common, and 2 sense terminals. And just from the, I'll show you a diagram of them too, but just from the length of the fingers as they make contact with the rotary encoding portion of the switch, the make-break ratio will either go from common, as you're turning it one direction, it'll break on contact 1 and then 2, and so forth. And if you're turning it the other direction, it'll make and break on contact 2 followed by 1. That's how the system determines what way you're turning the switch. And what can happen is these encoder, the actual switch portion, which is typically a silver type or silver plated disc, they get dirty and then you get errors created. So typically we got to take them apart and spray some contact cleaner into it. Best way to get at this is to remove the front panel. I think on this, the whole front panel should, by removing a couple of screws, should come off. I got 2 screws on the sides and 3 on the bottom. So let me remove the front panel, then I can remove the circuit board and lift the entire circuit board out. But I want to get the panel off first, just to make it a little bit easier for me to do that. So let's remove the screws that hold the front panel on. Got a couple ground screws I'd take out here as well, I believe. couple of flat cables to unplug. Now I can separate the front panel from the rest of the unit. I don't need to take it all the way off, but I do want to remove the screws here so I can remove the front board so that I can actually get at the encoder switch, which is right here in the corner. Screws removed, the board will lift out. And here's the encoder switch. I'm going to remove it from the unit itself so that I can actually open the encoder switch up and clean the contacts internal. So I have to unsolder it here. There's just the 3 terminals on the back here. Just 3 terminals plus the 2 tabs that hold it in place. So I'm going to warm up my iron and we'll take that control out. That way I can open the control up and actually get into it and polish the contacts up, much like we do on a VCR mode encoder switch. Removing the encoder switch and opening it is the best way to ensure that the contacts are cleaned. Some people might just try to spray some contact cleaner in. That generally doesn't work that well because you want to be able to actually polish the encoder switch itself. Make sure that the contacts are good and clean. Digital attenuators would have audio files rolling over in their graves, at least dead audio files. Thought of using a digital control to control volume in the analog world is something that's a bit of a dirty word to the true blue audio files, but this is the way that modern amps are, because of course everybody wants remote control devices, and for a while there they were actually using small motors, and some of the companies still probably do use a mechanical motor, a little gear driven motor, to physically turn the control. That was pretty common for a while, but you don't see too much of that these days. Everything has now gone to the electronic attenuator. It's just cheaper, and whether it's I wouldn't say it's better, but it's it costs less to make an attenuator type like this using an encoder switch. Fewer parts, just have to bend the tabs on the switch, and then the back should come off of it. So if I bend these tabs open, I should be able to separate the switch itself. Like this. And here is what I'm talking about. This is the guts of the encoder switch. You'll see that it's actually kind of gummed up. But here are the contacts, and here is the encoder itself. And as the diagram I showed depicts, there's 3 contacts here, and there's a slightly different length on these 2, as you can see here. One is slightly longer than the other. One is a common, it provides a common connection to this disc, And then as the disc rotates, the make break to the other two will be slightly different. I think my camera's having a little bit of a focusing problem there. Just zoom it back a bit so you guys can see it a little better. But anyway, this has got to get cleaned up. This is really, it's gummed up. Like it's almost like it's a grease that's on there, but it feels like a silicone grease, like the type they'd use for dampening a tone arm. But anyway, we're not getting a good connection. So we're going to clean this up, and I'm going to get some contact cleaner. We'll clean this up with deoxit. Use a D100 pure spray on this one. Now you may have wondered where that silicone type grease came from. Well, that's what they use in the bearing here of the shaft to give it that resistive feel, so that it has that feel of a real control. It gives it that resistance, and well, they just put so much on there that it just gets into the control and starts to cause problems. So we'll take that, we'll put the control back together. Put the switch back on here, and I'm going to give it another shot of some deoxit just onto the contacts here. To hopefully keep things clean. And then we'll put the back on the unit and bend the tabs back around. That's if I can find my needle nose pliers. They're never where I need them. They're right here on my bench. It's almost time to do a big cleanup of the workshop. Spring cleanup is coming. You can see a lot of stuff disappear from here over the next couple of months. I'm actually selling off some of the equipment that's mine that I've sold. I've got inquiries come in every day to buy my old equipment, so some of it's going to go to a new home. Okay, time to put this control back in, and then we'll test this amp and see whether I can actually control the volume. And actually some of the equipment goes to viewers, because I get people that they'll see something that I've serviced, and I'll get an inquiry and people want to buy it from me. And say everything that's mine is available to be purchased, reel-to-reel machines and so forth. The biggest expense, of course, is shipping. Shipping is what kills everybody, because some of these units are quite heavy, and the cost of shipping them is just in the stratosphere. This amplifier here would not be considered a real high-end amp. It uses power modules. Pioneer. They're all Pioneer. These are PAC007 and PAC008. There's two 007 and two 1008. So the 008, I believe, is the mono center channel, and the other ones would be the rear and front, left and right power amp channels. Okay, get this connector back in. It's kind of in an awkward place. Okay, I can turn this thing on now and see whether the volume control does anything. Okay, power on. That's what it's supposed to do. Turn on the speakers. Where's my speakers on this thing? Speakers A. Okay, left channel's working. Okay, the unit's working, and it is stereo. That speaker's further away from me, so it's not as loud, but it is on. You guys don't hear it now because I'm just using a mono microphone. Wonder what some of the modes are here. We've got Pro Logic, music, okay, there's stereo, DSP mode, it's probably not going to pick up anything on AM without an antenna. You can pretty much guarantee that's not going to pick up anything because there's no antenna on it. But I don't need to bother with any of the other inputs because it was the volume control that was the problem. And now the volume control is fixed. So when you have one of these any of these units, and it doesn't matter whether it's a Pioneer or a Sony or a Technics or any of them, any of these units that you can turn this control forever and it never stops. Okay, if it can turn forever, it's a rotary encoder. If it's got a knob that turns forever, it's an encoder. It's going to be a mechanical encoder. Yes, there were some optical encoders, but I've only seen the optical encoders used once, actually. I think I saw one on an old ICOM. I think it was a 241 ham radio. It was used to change the frequency, and it was an optical encoder on that. That's pretty much the only time I've ever seen optical encoders, although they would be possible. You could do it the same way. It's just that a switch is a lot cheaper and just as reliable, because the optical ones, you have to worry about the LEDs wearing out on them. But anyway, any of these units that use one of these encoders, if the volume control appears to be flaky, that is what it's going to be. Take it apart, clean out all that gunge, that grease that basically migrates through. That grease was put in to give the resistance on the knob so that the knob just didn't spin forever. It was to give it some resistance so that people were thinking, oh, I'm really turning a knob. No, you're not. You're turning a switch. But that was the idea behind that silicon oil. And it does migrate into it, and it just gums everything up. And then you end up with the type of problems that this one had. Anyway, that's it for this one. Thanks for watching, and we'll catch you in the next one again real soon. Bye for now.